What's up, guys? So now we're gonna do pointer problems. Pointers is a topic that everyone has trouble with, but hopefully with pictures that I'll be drawing a lot, this will help you. One of the things that people don't do when they do pointers is not draw. So drawing is key because otherwise it's too abstract. So first problem is to create an integer and print the address of the integer. So first things first, I wanna show you guys something. So my drawing thing here. When we create a variable, let's say called x, there's always a couple of things going on here. So this will have a value. So that's why when you say x equals 3, you have a value. And you have an address. So an address will be a hexadecimal. So we know it's hexadecimal because of this 0x. 0x doesn't mean anything, just means it's hexadecimal. It's a weird convention, but this is what people decided to do. So when I'm saying to print the address, we're used to printing the value. So we're used to print 3. How do we print the address? Whenever you see this sign here, right away you should think of address. So if you wanna get the value of x, you would print x. If you wanna print the address of x, you print ampersand. So the name of this character is called ampersand x. So x is the value, which is 3. Ampersand x is the address, which is 0xa. Okay? Awesome. So now how do we do that in practice? So we're gonna do that right now. So let me just bring this here, take this out. So we create int main void as usual. Let's not forget our include stdio.h. And finally we need to declare a variable called x that will hold the value of 3. And if we wanna print the address, the placeholder for address is p. So we saw d or I for integer, f for float. So for address is p, and we do ampersand x. So bringing back this drawing, we're gonna print. So this is x has 3, but we're not printing the address, we're not printing the value, we're printing the address. So let's compile this. Make problem 1. And you see like a random hexadecimal, so we don't really know problem 1. So this is the address. We never know exactly what the address will be. This is given to us by the operating system. But what you need to understand is this pictorial representation here. If you understand this, all pointers ideas will become easier. So now let's go to problem2.c. So problem2.c, let's see what it is. Problem 2, we're going to create an integer and grab the address of the integer and dereference it. So int main void include the library. So let's bring that picture again. So I told you guys that the ampersand represents an address. So this is an address. When you just print the variable, that will print the value. And then there is a third sign, which is the star. This is called dereference. What dereference does is, it says, take this address and give me the value. So for example, 0xa, if we did star 0xa, this is the same as saying give me the value at address 0xa, which is 3. Okay? So dereference means go to a particular address and give me the value. So what we'll do here is to grab the address of x by doing %x, just like we saw in the previous problem. We saw that this will give us 0xa, the address. This 0xa is not the true address. Like I said, we saw the last address. That's a fake address that represents the address of x. If we wanna, so this will return to us 0xa. 0xa. But if we want to grab the value at 0xa, we do dereference. You might be asking yourself, couldn't we do that by just doing printf x? For sure. I'm using this as an educational tool. It's nothing you'll see in real life, but this illustrates the idea of dereferencing, which has other use cases which we'll see in the next problems. But understanding that this is the same as saying, hey, take the address I have right now and grab the value. That's a key aspect of understanding pointers. So again, let's take that example from the previous problem. We're going to create a variable called x, and now we're going to print an integer because we're going to dereference the address. So we're going to do star %x. Remember, this is the same as just printing x, but think of this as grabbing the address of x and then grabbing the value at that address. Okay, so that should give us 3. So we make problem 2, and we're gonna run this problem 2, and we got 3, which is what we expected. Okay, so we saw dereferencing, we saw how to get an address. So now we'll actually, so these are introductory concepts, so we can actually talk about pointers, which is the next problem. So the next problem we're gonna create, let me bring the problem statement here. We're gonna create an integer, create a pointer to an integer. So what is a pointer? If you understand the picture, everything gets easier. So again, let's say we have x, we have 3, and we have this like 0xa. A pointer is a variable. A pointer is a variable itself. So I'll call this pointer ptr. A pointer also has an address. It's just a regular variable. What's the only difference between a regular variable like x and a pointer? That instead of holding a value like 3 or 4, a pointer holds other variables' addresses. So what ptr will hold is the address of x, which is what? 0xa. Observe it's not holding 3, which is the value of x, it's holding the address of x. Also, a way we can represent this is by doing an arrow. So an arrow going from the pointer to the variable. So if you look at this, we have a pointer from ptr to x. So how do we do that? Let's see. So we do include standard library and int main void, and then we're gonna basically create that variable x again. And we're gonna, the way you create a pointer is by doing this star ptr. Observe, this is what a lot of students get confused. This star here, we're not dereferencing ptr. The star, unfortunately, for educational purposes, it has 2 roles. It either serves as dereferencing like we saw last time, but if it's on the left hand side of the equal sign, it's a declaration of a pointer. So first you declare what type you're pointing to. So here we're pointing to an integer, x. And we use a star to say, hey, this will be a pointer. So we're not dereferencing. We're not trying to go to get the address of PTR and dereferencing it. We're just declaring. And what is this pointing to? This is pointing to num. So after we do this, we'll get this picture. So we'll have a variable called PTR that has the variable as a value, the address of x. But the pointer itself has its own address, if you know what I mean. So inside of the value it holds is the address. And now we can do some interesting things. So the first thing we want to do is to print the address of the pointer. What's the address of the pointer? So take a second to think about that. So think think to yourself right now. Is it 3, 0xa, or 0xb? What's the address of the pointer? So the address of the pointer is 0xb. Where is the pointer memory? The value is 0xa, but the address of the pointer is 0xb, is where this variable is located. So this is the first thing we have to do to print the address of the pointer. To print any address, we need to use the address placeholder p, and we need to use ampersand. Always when we talk about address, automatically it should come to your mind using ampersand. So if we want to get the address of the pointer, we say ampersand ptr. So I'll compile later. Now we want to print the address of the integer. So we've done this already. Remember, we can use ampersand x. But I want here you to using the pointer. So instead of doing ampersand x, is there a way I can print the address of x through the pointer? Sure. That's exactly the value of PTR. That's the 0xa. Observe the 0xa is the same that I have as address of x. So what do I do? So this is also a address, so I'll use the placeholder p. But instead of using ampersand x, I'm gonna just say PTR. That gives us the value of that. Okay? Awesome. So finally, we want to grab the value of the integer by using the pointer. So look at this picture again. PTR holds the address of x. Remember, we saw in the last video that if you use star, you can grab the value at that address. So we just saw that we can get the address. We can get the address of x by just printing PTR. So what if we did something like this? We printed. Now we're gonna print the value, right? And what if we dereference PTR? Because if we dereference PTR, what does that give us? If we dereference PTR, that will give us, so that means take this address 0xa and grab the value. What's the value of 0xa? 3. So we should get 3 when we print this. So we make problem 3. 1 second. So use of undeclared, yes. So we want to get, because I change to x. So we make problem 3 and we run that. So let's try to think here. So this address here is the address of the pointer of PTR. This address here, when we print PTR, this is the address of x. You can see that's the address of x, because if I do, this is a good way to visualize. If I do PTR, or if I do ampersand x, it will print the same thing. So make problem 3. problem 3. So observe that we printed the same address twice. Why? Because we can print the address of x using ptr, because that's what's here, right, in the variable, or we can use ampersand like we did in the last problem. And then if we dereference ptr, we go to this address and grab its value. What's the value at this address? It is 5, which is the value of x. Okay? Take your time, go back to the problem, to these explanations. If you didn't understand with me, no problem. You might see other explanation that makes more sense online, but this is a hard topic, so it really is worth going over this many times. One tip that always people only understand, in my personal experience teaching people, only understand these ideas of pointers once they start drawing. So take a piece of paper, get a pencil and pen. Every time you create a new pointer, do that square that I did, you know, this square that I'm showing right now. Try to do that, because then you're not thinking in terms of like abstract ideas. It's actually like a physical thing that helps a lot with visualizing. And if you're doing an interview in the future, they actually expect you to draw stuff because that helps with your explanation. So it's a good practice to start right now. So we want now to create a function that swaps two integers. So we want to swap them by first. So let's take one step at a time. So main void, we're going to create a swap function. So before moving on, I'm going to talk about swapping like this. So int x, int y. This is a very important idea. So if I want to swap something, think of it this way. If I want to swap, for example, this is x and it holds the value of 3. This is y. Oops. This is y. It holds the value of 4. If I say something like x equals y, y equals x, look what happens. When I say x equals y, I'm gonna overwrite the value of x, so this will become 4. But when I say y equals x, my x now has been updated to be 4. So I'm saying y equals 4, but y is already 4, so I didn't actually swap. So I need a temporary variable. Okay, so basically what we want to do is we want to first put 3 in this, so let's call this temp. Oops. Let's call this temp. Let's put 3 in temp. Let's put 4 in x. And now let's update the value of I with what's in temp. So now we swapped the values. So that's what we're gonna do. We're gonna say int temp equals x, x equals y, and y equals temp. So far so good. And we're gonna create two variables, int a equals 3, int b equals 4. So we're gonna call swap with a and b. After we call swap with a and b, when we print it, a should print as 4, and b, so a should be 4, b should be 3. So I'm gonna print a, and I'm gonna print, oops, I'm gonna copy and paste. I'm gonna print b. So let's compile, and hopefully this will print 4 and 3, which means the variables were swapped successfully. I forgot to put the function at the top. A very common bug, mistake. If you're watching this video, you probably have enough mileage that you face this error at some point. So we're gonna do problem 4. And now we're gonna run. So this is the issue. We're still printing 3 and 4 instead of 4 and 3, which is what we expected when we called swap. And this is a very important concept in programming, so pay attention to what I'm gonna say next, because this will be very important. So when you call a function, let's say I have a equals 3, b, let me make this lighter, because then it's easy. So a equals 3, a, b equals 4. When we call a function like this is a very common misconception. When we call a function, we're creating clones of a and b. So x and y, that's sometimes why people call this a and b as well, the same name as when you're calling. It gets confusing because you think that this a up here is the same as this a up here, in case this was named a, but it's really not. What happens is when you call a function, you create a clone of a inside of this function swap. So this clone will also have the value of 3, but it's not gonna be a, it's gonna be called x. Even if you called x, so this will be 4. Even if you call this a and b, even if you call this a and b, they would still in memory look different. So in memory, even though this would also be called a and this would be called b, this is a different a from that. So when you swap, so obviously swap is gonna work because we do that temp thing that I just explained. But when you swap, this variable NAB, because when we exit swap, the variables that are inside, they get out of scope, meaning they are not available anymore for us. They disappear. So we did swap 3 and 4, but we swapped the clones of A and B, not A and B themselves. In order for us to actually swap A and B, we need to pass the address of A and B, not the values. This is called this is why what I just did, this wrong way of swapping things, is called passing by value, because you're passing and creating a clone of the initial variables, and passing the address is called passing by reference. So to pass by reference, we're gonna when we swap, we're gonna send the addresses of A and B. So that's our first step, swap by first passing the addresses of the integer. Remember that if we wanna use addresses, we use ampersand, and we'll have pointers. So this is actually x and y. X and y will become pointers because only pointers can hold addresses. So we'll have a pointer x, a pointer y, and we need to change certain things here. So we want to grab the value, x will be pointing to an address, right? So let's draw this up. So let's start over. So I will have A, I will have B. When I pass the addresses of A and B to X and Y, what I'll have is something like that. I'll create a pointer called X that points to A. And I'll create a variable, a pointer to B called Y that points to B. So Y is pointing to, remember that A has its own address, let's say 0xa, and this is what X will hold inside 0xa. And B also has some address, let's say 0xb, and that's what this pointer will be holding, 0xb. So when we say temp equals x, this won't work because x is not holding a value, it's holding an address. If we wanna get the value at the address 0xa, which is what we really want, we want 3. We don't care about 0xa. We're not swapping the addresses, we're swapping 3 and 4. So if you wanna put 3 in temp, you need to dereference this. So dereferencing using a star. Okay, so by doing that, my temp right now will hold the value of x, which is the value at address 0xa 3. So right now temp equals 3. Now we want to say that a has the value of b, right? But observe that here we don't have access to a and b, we have access only to these pointers x and y. So we want to grab the value of y, the value that y is pointing to, so we need to dereference this y. So that will give us 4. And to update the value of x, so to update the value that x points to, we also dereference x. So this will basically, we'll do this, so we're actually dereference x as well. And what we'll get is something interesting. We're gonna come here, and this will be written, this will be 4. So this will be 4 now. I forgot to say, yeah, so we'll have a temp from line 20. So temp will be 3. And finally, we want b to hold the value of temp. Temp is an integer, so we don't need to dereference, so this is good. But we need to overwrite the value of 4 to become 3. So we dereference y. We dereference y. And if we compile this, if we make problem 4, again, same mistake, I need that to say that this is a pointer, we put a star, and I believe we're good to go. So make problem 4, and now it should print the swap values 4 and 3 instead of 3 and 4, because we actually exchange through this pointer game that we just did. We actually, oh, I forgot to change this to 3, so this will be 3. We actually changed the original values, not the clones like we were doing before. Okay, so the other thing they want us to do is to swap them back. So we're gonna swap first to 4 and 3 and then back again to 3 and 4. So we need another swap call, passing as arguments pointers to the integers. So let's first create these pointers to the integers a and b. So we're gonna call this int r, and it's gonna point to the address. Hopefully by now you understand this, we've explained in problem 1. And then we're gonna have a pointer that will point to address of b. So now we're gonna call swap, but with r and s. So why does this work? Because r, we're doing something similar to what we're doing before. So we're gonna create here, this will be r, no, so this will be s, and we'll also hold 0xb because we pointed to that originally, and it's gonna point to this. So this is an s, guys, sorry about that. Now let me fix this, this is too ugly. So let me make this a little bit better. So this is an x, and this is 0xb, 0xb. And then we have this variable r that has 0xa that points to this. So when we pass R and S, again, we're passing the values of R and S. But what are the values of R and S? 0xa, 0xb, which are the addresses of A and B. So that also swaps the original values. So we can either pass them directly by using the ampersand on the original values, or we can create pointers, but those pointers will also hold ampersand A and ampersand B, which are the addresses. This is another way of putting the addresses somewhere. So if we pass R and S, they will also pass the addresses, the original addresses of A and B. And when we compile this, we're gonna get, oh, let me print this, otherwise we won't know. Yes, so we should see 4 and 3, and then 3 and 4 because we swap back. So 4 and 3, 3 and 4. All right, so hopefully you guys understood this. This is tricky, so this is tricky. But hopefully the drawings help clarify a bit of the confusion with pointers. So now we'll do problem 5. Problem 5 is, let's do this one. This is a good problem. Problem 5.c. So I want to create an integer. So include studio.h int main void. So first thing, create an integer. So int x equals 4. Create a pointer to that integer. By now you guys should be experts in this. So we're gonna call a pointer called ptr that points to the address of x. Create a function that takes the pointer as input. So let's first create a function and adds 1 to the integer. So since it just adds 1 and we're passing the original address, it's gonna be void because we're not returning anything. We're just adding 1, and since we're modifying the original address, there's no need to return anything. So we're passing the pointer, right? So we're gonna call add1 with ptr as an argument, and we need to have a pointer that will use inside of the function. So let's call this p. So the way, let's put this up here. The way that we can add 1 is relatively, we can do in one line. So what does star p does? Star p will grab the value that p points to. So let's draw this. If you're a programmer, you actually should hone your drawing skills. So we created x, it will have the value 4, and it will have some other, it will have an address, 0xa. Then we're gonna have this pointer called ptr. ptr will hold the address of x, so this is pointing to x. So this will have inside the same, the value of ptr will be the address of x. When we call add1, and since we're passing ptr, we're creating another pointer called p, which also holds the address of x, 0xa. Let me do this in another color. 0xa. This is called p. 0xa. So to add 1, we can dereference p. So dereference means go to the address that I have, 0xa, and grab the value and add 1, right? Makes sense. We're just grabbing the value and adding 1. But we need to reassign it to the original value. So we need to update this 4 to become 5. The way we do it is we also dereference in the assignment. We're gonna say p equals star. First, it's always on the left right hand side that gets run, and then we reassign it to p. So if we print fx after that, so this will be an integer. If we print fx, we should get something interesting. So we're gonna say make problem 5. I forgot a semicolon. I'm used to Python. And then we're gonna run problem 5 and we print 5, which is 4 plus 1. Makes sense? So hopefully this kind of helps understand the previous problem as well, where we did the swap, when we did that with different things. So now problem 6, we're almost done, guys, so hang on. I know this is some dense material, but this is important to master. So problem 6, you need to create a char pointer to a string with 3 characters. So this is a bunch of complicated stuff I just said, but let's translate that into English. So we wanna create a char pointer, so a char pointer. So our char pointer, the char star. If it's a integer pointer, inter star. So char star, and then we give the name to that pointer. I'll call this PTR as well. That gets us that points to a string. So a pointer can also point to a string. So it's not only to integers or something like that. It can point to a string. So this point, when we point to a string, it always points to the first letter. So if we want to print the first letter, we can dereference PTR. So this will be a char, right? Oops. We dereference and then we do star PTR. Star, let's call this S from string. I'm gonna do star S. So since a pointer to a string always points to the address of the first letter, this should print H. So I'm gonna do make problem 6, and then problem 6, this should print H, and it does. If we wanna print I, which is the next letter, I can do some pointer arithmetic. So that's what I say here, print each character, not character, using pointer arithmetic. So if I wanna print the next character, and this holds true for arrays as well, guys. So if you create an array and you wanna print the second element, you can say the pointer plus 1. So that basically goes from H to I to the address of the next letter, address of I. Dereference that address now. So we're currently currently always pointer to a string or to an array points to the first letter or first element of the array. When you do plus 1, it goes to the second address. Now char S is pointing to I, to the address of I, but now we want to print I itself. So we use the star for the referencing. And to print the last character, it will be very similar. We do just S plus 2. And we should get high exclamation mark. So make problem 6. As usual, I forgot something. What did I forget? What is he complaining about? He's saying that there is not... I forgot to close here and close here. No problem of having bugs, guys. So when you get bug, it's the most normal thing in the world. But as you get more experience, you start catching them faster. So problem 6, HI exclamation mark. So this is how we can print. This is called pointer arithmetic. Finally, last problem of our list, problem 7.c. So problem 7.c will be for us to ask the user for an input, copy. So let's come here. We're gonna import a bunch of libraries here, so don't get scared. But cs50.h to use getString, standard library, string.h, so we can use strlen. If I'm not mistaken, strlen comes from this or that. Anyway, so we want to ask the user for an input and copy the string from one to the other. So basically, if I create that high exclamation mark, I want to copy that to another variable. So let's first ask the user for an input. So int string, no, string, no, so he wants us to use a pointer, right? So we'll do that and then use getString. Give me a word, \n. Let's see if this works. I'm not sure this works, so cs50 sandbox problem 7. It does. So if we do problem 7, we're gonna say apple, and that's it. So far so good. So we have a pointer to a string. Which string? Whatever I write on the terminal. To copy, you might think we could do something like that. So chart t equals s, chart t equals s. So if we printf, if we printf s, let's dereference s, because we want actually the value that s points to. And then we print t, we're gonna have a surprise. Surprise. So we're gonna make problem 7. And if we run, we should get whatever I wrote, apple. It's actually, so let's actually change this to s. I think this will work because we don't want to remember, this shows that the char star prints only the first character, right? But since we want the whole thing, yeah, this wouldn't work. So these we're just gonna see the first letter. So print s, but let's use pointer arithmetic. So actually let's grab stuff from the last problem, so that way you guys can see. So I'm gonna do this for s and for t. So I'll do high again, and you guys will have a surprise now. So the surprise before was that I made a mistake. Now the surprise hopefully is what I intended. So apple, and so we see not apple. Let me do high exclamation mark, which only has 3 characters. So high exclamation mark. We should see high exclamation mark, high exclamation mark. So apparently we copy the value of s to t. But what if we do something like that? We say that t0 is equal to toUpper. So toUpper is a function in C that makes the whatever letter you have uppercase. So let's say, so this should just make my T uppercase, not my S, right? So let's compile problem 7 and problem 7, and I'm gonna say apple. But observe that both the first, both S and T became uppercase, but I just uppercase my T. If you look at my code, I just said T0 equals to upper T0. So let's see what happened. What happened was that I create a variable called, so this will be apple. Let me make this larger. So apple, apple, s will point to this. But when you say t equals s, we're actually creating, so this is a pointer. We can do like a little square like that. We're making both s and t points to the same string. So we didn't copy the string. We wanted to copy, we wanted to create another apple here. What we did was to create a pointer and point both s and t to the same thing. So if we change, for example, from A to B, when we print S0 and T0, both of them will print B, which is not what we wanted. We want a copy. So to copy, to create a new string, we need this function called malloc. So malloc creates space in memory for us. So how much space do we need? We need to whatever the size of the string that I just wrote is, using getString, so that's what I'm doing. I need a +1 though, because remember that strings have a no character in the end, a \n, so we need space for that as well. Okay, so now we are allocated memory for t. We allocated memory for t. But if we now uppercase the first letter, you guys will see that it doesn't change. If we uppercase t, it's now not changing as. Why? Because I created space for a new memory. But first I need to, what do I need to do? I need to copy the letters over from S to T. So I'm gonna say int I equals 0. I can declare two variables in the same for loop. So whatever comes before the first semicolon is declaring the variables. Usually we're used to just declaring one, but we can say something interesting. We can say that n equals *len s. Okay, so we're saying here that my I starts as 0 and n starts as the length of s. And then we're gonna do the same thing. So I will be less than n and I++. We wanna we're gonna basically take all the letters from S and take it and move it to T. And now when we do something like to upper, like we did previously, so we did something like that, to upper T0. When we print f, s, and when we print f t, just t should be uppercase. Let's hope for the best. Let's do make problem 7. Include, yeah, so I need this library stdlib, which I forgot. So include stdlib, that's where the malloc is coming from. .h. Let's compile. So everything worked. And now if we run apple, okay, I have an extra. Do I have an extra? No. So this first apple is what I wrote, right? From the get string. Yes. But observe when I printed in the end, my s now is lowercase and my t is uppercase because we created copies. So malloc helps us create copies of the original things. So when you say malloc, you're not doing like pointing to the same thing. So when you say t equals malloc *len +1, we're creating another place in memory that will hold 5 values. In the for loop, you're passing one letter at a time from S to T, so T will be pointing to this. So P will come here, P will come here, L will come here. I have an extra spot here that should be here. So when I change this from B to, let's say, C, observe that I'm changing now a neo place in memory, not the original one like the previous. Okay, sounds good. So those were the key pointer problems that I think that are worth taking a look. Again, be patient with yourself because this is a hard topic. So you have to maybe watch this video, maybe watch others on YouTube, grab a book. Hopefully this clarified pointers to you. Watch the CS50 lecture that we suggest, and hopefully this makes pointers more clear. And pointers are important, not to get a job as a web developer or app developer, but if you want to dive deeper into computer science, which allows you to get like a job at a big tech company, a lot of the questions they ask in Google, at Google, Facebook, they require you to understand these more theoretical things, because a lot of structures that you might see in the future, but you'll see here in CS50 as well, like trees, linked lists, depends on this idea of pointer. So any questions, let us know. Hopefully you enjoyed this content, and see you soon.